Hi, Mitchell. Good evening. I hope I have pronounced it correctly. So my name is Prakash. So I am the math tutor for this webinar. Yeah, I hope you can hear me. Yeah, so we'll start the webinar in a moment. Okay, let's wait and see if anybody joins for some time. So I hope you know the today's topic. Today we are going to discuss about the applications of trigonometry. So maybe we'll start with the basics of trigonometry. Then we'll do some questions based on the applications. Yeah, let's start the webinar then. So, Mitchell, yeah, please let me know if you have any questions in between any of the time. Feel free to ask me. Okay, any questions? Please try to interact with me if you can. Okay, so I hope I pronounced your name correctly though. Okay, so this is the topic, the applications of trigonometry. Okay, so let's try and learn some basics first. So what is trigonometry? The trigonometry is one of the important chapter in mathematics. So we are going to learn, I mean, in the name trigonometry, trigon, trigonometry, tri means three, this gon means you can say sides, okay? So which means the trigonometry is completely depends on the sides and angles. Sides and angles. So it is three sides and three angles, because tri in a sense three. Okay, so three sides and angles. So which polygon, which two-sided shape will get three sides? Obviously, I hope you know that it's a triangle, isn't it? So the triangle has three sides. In that triangle, we have different types of triangles, but a triangle has three sides and three angles, we can say. So which means the trigonometry is completely based on the triangles, the relationship between the angles and sides of a triangle. Okay. Yes, welcome, Mohammed. Yeah. So trigonometry is completely based on the sides and angles of a triangle. So, but particularly we are going to deal with the right angle triangle. So the right angle triangle. What do you mean by right angle triangle? Where one angle is always a 90 degrees. So this is what a right angle. So trigonometry, I hope you understand the basic definition. So trigonometry, so three shapes and angles, so which means that shape is a triangle. So the trigonometry, usually use the trigonometry, or in the trigonometry we are going to use the relationship between sides and angles of a triangle, particularly the right angle triangle. So this is what the right angle triangle looks like. This is how, and let's name the triangle as ABC. This is a triangle, and you can just see angle B is 90 degrees, and we do have angles at A and C. A and C are the complementary angles. I'll explain in a moment, okay? And let's say the length of BC. So this is a length, and this is also a length of AB, the height, you can say. And this is the hypotenuse side, which is the longest side of a right angle triangle. Okay. So then what I mean to say in a complementary angles, I hope you guys know in a triangle we have three angles. All three angles add up to what? Sum of three angles. Sum of three interior angles of a triangle is 180 degrees. So for example, if we say ABC, where B is the right angle. So angle A plus angle B and angle C add up to 180 degrees. I hope you guys are aware of this. And here, as you see, clearly given the angle B is a right angle. Angle B is a right angle, which is 90 degrees. If B alone 90 degrees, and what is A and C then? So A and C, the sum of A and C is 90 degrees. Because A alone 90, I mean B alone 90, the combination of A and C becomes a 90 more. So which means what? So if two angles add up to 90, if two angles add up to 90 degrees, then those
Hi,
angles
sir.
are called as complementary angles. Yeah, hi Mohammed. Have any questions? Yeah, I hope you can hear me. So if the two angles add up to 90 degrees, those two angles are called as complementary angles. What do you mean by complementary? If the two angles add up to 90 degrees, those are called as complementary angles. So please let me know so far if you have any questions. So this right angle, one angle is 90 degrees, which means the other two so those two angles, one is angle A, angle B, or that's complementary angles because hello, Mohammed, can you hear me? Hello, hello, guys, can you hear me?
Yes, sir. Yes, sir.
Okay, okay, sorry for that. So what I was saying, the two angles add up to. Okay, thank you very
90
much.
degrees.
Yes, one angle alone 90 degrees, so that is nothing but a right angle, and the other two angles add up to 90 degrees. So those two angles are called as complementary angles. For example, here angle A and angle C are the complementary angles because complementary angles itself is a 90 degrees. Okay, if two angles add up to 90 degrees, those angles are called as complementary. Okay, so now let's try to learn the trigonometric ratios. So in this triangle, let's say this length, the base length as a and the height as a B, and this longest side as in the hypotenuse side is nothing but a C. So we have to use the Pythagoras theorem. I hope you guys know that the Pythagoras theorem. So that is nothing but the sum of the square of sides equals to the square of hypotenuse sides. What I mean to say, a square plus b square equals to the c square, where c is the longest side, guys. This is the Pythagoras theorem. We are going to use this theorem to find the unknown side of a right angle triangle. Okay, so we'll try to learn some questions. Okay, for example, if we have so if we have a 12 centimeters and this one is a 5 centimeters, how do you find the longest side? We are going to use the Pythagoras theorem, isn't it? Which is nothing but a square plus b square equals to c square. So where a is the height or a base, okay? A and b is nothing but the height and base. C is the longest side, which is hypotenuse side, okay? So what is A? Let's say 12 square. What is B? 5. So 5 square. So and we need to find C here. So what is 12 square? 144. 5 square is 25. So C square equals to 169 if you add. And C equals to square root of 169. What is square root of 169, guys? Which is 13 centimeters. So the length of this hypotenuse side is 13 centimeters. Okay, so this is a basic question. I hope you guys are able to follow me. If yes, we'll go to the next question. What do you think, guys? What do you think, Muhammad? Mitchell? Okay. Let's say this is 4 centimeters and this one is 5 centimeters. What is the side length or a height of a triangle? So how to find this? Any idea, guys? So we are going to use the same formula, which is Pythagoras theorem. A square plus b square equals to c square. We just say a is 4 square. We need to find height. Let's call it as a b. And c is given, which is 5 square. So 16 plus b square equals to 25. Move this 16 to the other side. We'll get b square equals to 25 minus 16. So b equals to
6.4.
No, b square equals to 9, right? And what is b? Square root of 9.
Oh, sorry, sir. 3. Sorry, sir. 3.
3. So 3.
I thought like, so sorry, sir. I thought like if you add, I got
Okay.
3. That's why.
Yeah. So, but when this is always C, okay? We just need to assume the longest side is always C. You can interchange the A and B. This height and the base is nothing but the A and B values. You can take it as, okay? So I hope you guys understand. So these are the basic, the Pythagoras theorem questions. Okay? So then we have a trigonometric ratios. Trigonometric ratios. I hope you guys heard of ratios, the trigonometric ratios, which is we have a 6 trigonometric ratios. I hope you guys might have some idea. If you want to share with me, please go ahead, else I will explain. So for example, just consider, so just consider this is a right angle triangle A, B, and C. So in an angle, we do have an angle of a right angle, isn't it? So this is 90 degree, that's fine. But you can take either C and A as an angle. So I'm going to pick C as an angle here. Okay. So for that, we have a 6 trigonometric ratios. The first one is nothing but sine.
Sine theta.
Sine theta.
OH. Cos theta.
Cos theta. Very good. Cos theta.
Then you have tan theta.
Very nice. Yeah. Tan theta.
Sir, I forget the last three.
Okay. So which is cosecant theta. COSEC. Cosecant theta. The second last one is secant theta.
Then
And the last
sine.
one, cot theta.
Cot.
Okay, so if you want me to write the full names, I will do that. SINE, sine theta. This is nothing but a cosine, which is nothing but a cos. Cosine, COSINE, okay, cosine theta. And the tan theta, tangent. Tangent is nothing but a tan theta. Cosecant is nothing but a cosecant. CENT.
ENT.
Yeah, so cosecant theta. And secant. Yeah, secant theta. Finally, cotangent. Cotangent.
Tangent.
Theta. Okay, so these are the complete names, and please try to remember all the ratios. It starts from a sine, cos, tan, cosine. So this cosine is can also be written as CSC. Okay, CSC theta is nothing but the cosine theta, guys. Okay, and then secant theta, cot theta. So these are the 6 trigonometric ratios, guys. Okay, so how to find these trigonometric ratios and why and when we use these trigonometric ratios? Okay, by using these trigonometric ratios only, we are going to proceed further in the trigonometry, you can say, because these angles. So this each one is represents or depends on a relationship between that angle and to the sides of a right angle triangle. So for example, if you want to find the height of a tower or an angle, and on what angle you are looking at the tower, or find the hypotenuse side of a ladder. So all these basic real-time examples are word problems will be done using these trigonometric ratios and the Pythagoras theorem. Okay, let's try to learn quickly a few how to find the ratios. I mean, okay, let's say this is a triangle, guys. This is a right angle triangle, guys. And let's say this is the angle we are going to concentrate. So this is the angle we are going to use. So let's assume this is a theta, guys. And I will give the values as this is 3 centimeters. This is 4 centimeters. And if you use correctly the Pythagoras theorem, will get this as a 5 centimeters. Okay. So now what you guys need to do, we need to find the trigonometric ratios, all 6 trigonometric ratios of this values or this triangle. So how to find? The first one, the formula, sine theta. I think we have a formula. If you want to remember, let me write that.
Sine theta is called over H. So cut हुआ, yes.
Yeah, and then C A H T O A. Okay, so please try to remember this logic, guys. If you want to remember, I mean, if it is confusing, please remember this logic. Okay, see, in this one, if this is a theta, the opposite of that angle, see, this is an opposite of an angle. So this side is nothing but an opposite side. The adjacent to that angle is nothing but adjacent side. And the lengthiest side or a longest side is always called as hypotenuse side. Yeah, so which is nothing but if the angle, I mean, the side which is opposite to the right angle is nothing but the lengthiest side, which is the diagonal side, we can call it as, or else hypotenuse side. So if you know this, so just have a look at the logic. O stands for, in this one, O stands for opposite side, and H stands for
Hypotenuse.
hypotenuse side. Yeah, hypotenuse side. And we do have one more, which is A. So A stands for adjacent side. And finally, you might have a question. The starting letter S in the first one. So S is nothing but a sine theta. And in this one, we have cos C. So that is cos theta. And in the third one, we have a T. So that is that first letter represents the ratio. So SOH. S represents sine theta. What is the formula? OH, opposite side divided by hypotenuse.
Opposite of hypotenuse.
Yes. The cos theta, C stands for cos theta. AH means adjacent divided
Adjacent
by
over hypotenuse.
hypotenuse. Excellent. Finally, tan theta.
Opposite over adjacent.
O means opposite, A means adjacent. Yes. So these are the three formulas, guys, you need to remember. Okay, then what we can do? So how to find the remaining? It's a very simple. So, but you need to remember which one comes first, which is cosecant first. Cosecant is the fourth one. Cosecant theta is nothing but the opposite or a reciprocal of sine theta. Okay, so which means whatever the sine theta value you get, you just need to flip that or a reciprocal of that. So which means opposite by hypotenuse is a sine theta. Cosecant becomes hypotenuse divided by opposite. And what is the next one? Secant theta. Secant theta is the reciprocal of cos theta. Yeah. So which is, you just need to flip that, which is hypotenuse side by adjacent. You know, you guys no need to remember this one, okay? The sides for the second three.
But so this method looks this method looks easy.
Yes. So you can just remember the reciprocal method. Finally, cot theta is the reciprocal of tan theta. 1 by tan. I mean, that is tan theta.
1 by.
Yeah. So that becomes adjacent over opposite, guys. Okay, let's try some questions. I hope you guys remember the formulas now. So let's go ahead and find some examples. Let's say this is a 4 centimeters. This is a 3 centimeters. And the angle is this one, guys. The angle is this one. So this is 5 centimeters. If you want me to write the logic, SOH, CAH, and what else? TOA. Okay. Okay. So first one, just find the sine theta, guys. What is sine theta? So this is the theta. Okay. And if this is a theta, this is an adjacent side, and this is an opposite side. And you know that hypotenuse side is this one. So what is sine theta, guys? How do you find sine theta? Sine theta is opposite side. What is the value in an opposite side?
So the opposite side value is 3.
3. So 3 divided
And
by hypotenuse side is 5.
Sir, the answer is 0.01.
Okay. No need to write it in a decimal, Mohammed. Let's keep this as a fraction. Okay.
Okay.
Yeah. So second. Yeah. But that's a good one. Okay. So
next, we cannot simplify.
No, we can simplify, but not required. I mean to say, okay, we can simplify, but not required. Cos theta. I hope you guys know the formula for cos theta, which is adjacent
over hypotenuse.
Yes.
And
Uh,
tan theta is
4,
opposite
I,
over adjacent.
yes, adjacent side is a 4 and hypotenuse side is 5. I think Michael wants to say the answer for tan theta.
Kato.
So Michael, I mean, sorry, Michael, it's not Michael, it's Mitchell, I hope.
Michelle. Hi, sorry.
Michelle, sorry for that.
Yes. Opposite is 3 over, the adjacent is 4. So it's 3
Yes.
over 4.
Excellent one. So once we found the first 3, the remaining 3 becomes a little easier. I hope you guys know that. So what is cosine theta or cosecant theta rather, which is the reciprocal of sine theta? Can you please tell me, Michelle?
5 over 3.
Excellent. So Mohammed, would you like to try the next one, the secant theta?
Sir, I will do it.
Yeah. So which is the reciprocal of cos theta? So cos theta is 4 by 5. So this becomes a 5 by 4. And similarly, cot theta, the reciprocal of tan. So that is
4 over 3.
4 over 3. So that's it, okay? If you know this one, guys, I think that's very good to go next for the next set of questions, next type of questions rather. Okay, so this is one way of asking. They will give the right angle triangle, or else they will give the side values, and they will ask you to find the trigonometric ratios. You need to do this. In the other way, they will give the question like, if sine theta equals to 12 over 13, find the remaining ratios. You guys understand the question? So they have given just one ratio and they will ask you to find the remaining ratios. So what you need to do, just quickly draw a right angle triangle, guys. So let's assume this is a theta. What is given? The sine theta is given. What is the formula for sine theta?
Opposite over hypotenuse.
So if this is the theta, opposite value is given. This is 12 and this is given 13, which means we need to find this one. I hope everyone agrees to this. And then what you do, how do you find that? So this, you can consider this as a B. So you need to find A. You need to use C.
I think we can use hypotenuse Pythagoras theorem.
Pythagoras theorem, yes. So A square plus B square equals to C square. And A value we don't know. B is 12 square equals to 13 square. So A square plus 144 is 12, right? 12 square. And then 169. So if you move to the other side, what will happen? 160.
Answer is 5.
Yes. So A square is 25. A is 12. I mean, A is
5. 5.
So that's it. I think Michelle are able to follow me.
Yes.
Okay, then we can find the remaining ratios easily. So the first one, we already have a sine, so go ahead with the cos. What is the value of cos?
12 over 13. Cosine. Cosine.
Yeah, cosine.
5 over 13.
Very good. So what about tan theta?
Tangent.
Tangent.
Opposite over 12 over 13.
12 over 5.
Over 5.
Yes.
Okay, towa.
Yes. And we have the other three, so very easier now. Cosecant theta.
13 over 12.
13 over 12. And what else? Secant.
Secant.
13 over 5.
Very good. 13 over 5. Just the reciprocal of cos theta. And the last one is
cotangent.
Cotangent.
5 over
12.
Yes, that's it. Okay, so yes, very good, Mohammed. So you might get the questions like this, like what? They will give one ratio and they will ask you to find the remaining ratios. Okay, done?
Okay.
Yeah. So finally, I just want to add one more type in this. Let me do that quickly. see, that sides, that angles, this is not going to be opposite always. This side is not going to be opposite always, or rather this side is not going to be adjacent always, but this is an hypotenuse always. That's the fixed one, but these two varies based on the angle. What I mean to say, guys, if we consider this as an angle, the top one is an angle, can you please tell me which side is an adjacent and which side is an opposite here?
That
See,
one is opposite. Yes.
yes, the side which is opposite to the angle, given angle, that is
Mm-hmm.
nothing but opposite, and adjacent to
Yes.
that one is adjacent. Okay, so let's quickly try this. Let me give some values to you guys. Let's say this is 8, guys, and this is okay. Let's say this is 24. 8 is fine, I think. 8, 6. If we get 8 and 6, I think we'll ended up getting 10 here. Okay, so and I hope you guys know the trigonometric ratios here. Can you please tell me anyone?
8 over 10.
8 over 10, excellent. So but make sure to, I think we need to simplify, right? Simplify.
Yes.
Okay, so similarly cos theta is 6 over 10, which is
6 over 10.
3 by 5. Okay, and tan theta, I think you already know that.
8 over 6.
8 over 6, excellent one.
So,
that is,
sir, it will 4 over 3.
yeah. So on the remaining 3, you can be found easily by flipping the fraction, by taking the reciprocal. So please let me know, guys, if you have any questions so far. I'm done with the Pythagoras theorem part and the ratios.
No, sir, no, sir.
What about Michelle?
It's clear, sir. Clear.
Okay, that's very good to see. Okay, now since we are doing the class 10th topic, move to the next little tougher one topic, or an important topic, you can call it as, which is the trigonometric ratios using complementary angles. Ratios using complementary angles. What do you mean by complementary angles, guys? Anyone would like to share?
Yeah. Should be equal to 180.
No.
Complementary.
Complementary, in a sense, two angles add up to 90.
Oh.
90 degrees.
See only, okay.
Okay, so please remember that. Complementary angles is nothing but the two angles add up to 90. Only
Okay.
two angles. Supplementary angles, in a sense, two angles add up to 180.
Oh, okay.
Supplementary, but this one is a complementary. And let's quickly draw a triangle, guys, here. So as I said in the starting, we completely use the right angle triangle in a trigonometry, most part of trigonometry. So this one is obviously 90 degree. Let's say A, B, C. So this one is alone 90 degree. And what about A and C? What is the angle of A and C? Any idea?
Oh.
You guys know that A plus B plus C, all three angles add up to 180 degrees. That's the triangle.
Okay.
You already given one angle is 90 degree, which is B, right?
Yes.
So we left with the two angles, which is A plus C. So what is A plus C then?
90.
Excellent. So which means what? These two are the complementary angles. Angle A and angle C are the complementary angles because those two add up to 90 degrees. Does that make sense?
Yes.
Okay, so now I have a question for you. If angle A is 30 degrees, what might be angle C?
60.
So what you do, you just subtract that 30 from a 90, I hope. Is that the way you did?
Yes.
Okay. Mohammed, are you able to follow me?
sir.
Okay, so one more student joined, I think. So welcome. Okay, so now let's try one more question quickly. So there is a reason why I'm explaining this complementary angles quickly. So I think you know that this. So if this is, let's say, a 35 degrees, can you please tell me what is the angle of this?
55.
Sure.
Yes.
Yeah, very good. So this is 55. So which is nothing but what? You subtracted from a 90. So what I mean to say, just quickly draw one more. So if you think this as an angle theta, then what happens to this one? What might be that one then? If this angle is theta, we don't know the value, it's just mentioned as a represented as a theta. Then this is going to be a 90 minus theta.
Okay.
Everyone agrees?
Yes.
Mohammed, what about you?
Yes, sir.
Okay, good. So that's what, I mean, that's the rule we used in the previous question. So if one angle is theta, other one is going to be 90 minus theta. So if that means if this is becomes a 40, then this becomes a 90 minus 40, that is 50. I hope you guys understand now. Okay.
Yes.
So why we are using 90 minus theta? Because these two angles are complementary angles, as I said. This one, this A and C, if you want to call it as. So now let's go to the complementary angles of ratios. Okay, so I'm keep on drawing a rectangle triangles. Just bear with me a second. Okay. So the same thing, let's take this is a theta, guys. This is a 90 minus theta. Let's take some values, okay? So if you don't mind, will take the same values which we take. So which is 3 centimeters. This one is a 4 centimeters, and this one is a 5 centimeters. So I'm going to write the ratios, all six trigonometric ratios quickly. So sine theta becomes, I hope, please let me know if I'm writing wrong or something. 3 by 5. Cos theta becomes 4 by 5. Tan theta becomes 3 over 4. And okay.
Adjacent 4. Tangent is 3 over 4.
Yeah.
4 over.
I think you're right. I mean, tan theta is 3 over 4, isn't it? So
yes,
cosecant going to be reciprocal of sine.
5/3.
What else? Secant theta is going to be reciprocal of cos.
5/4.
And finally, the cot theta going to be the reciprocal of tan. I hope everyone agrees to these values of sine theta. So we assume theta as an angle. So we found all these ratios. So theta as an angle. I'm writing at the top. What if 90 minus theta as an angle? Okay, so can you please tell me the ratios of I mean, yeah, all ratios if theta is 90 minus theta. I mean, if the angle is 90 minus theta. So what happens to sine 90 minus theta? You understand what I mean to say?
Sine 90 minus.
So we are assuming, let me take a different color if I can. So we are assuming this as a theta now. This part as a 90 minus theta we have, right? That is an angle. If we are taking this is an angle, this becomes an opposite side, right? this becomes an opposite, this becomes an adjacent. I hope you guys know that.
Okay.
So please tell me, what is sine 90 minus theta?
It's 4/3.
4/3. Excellent. So 4/3. What about a cos?
3/5.
So cos is adjacent over,
3/5.
yep, tan. Tan 90 minus theta.
5.
4/3. And finally, cosecant. Muhammad, are you able to follow me? 3/5.
Yes, sir.
Yeah, and we have two more. Let me write that quickly. So please let me know if you have any discrepancies here. So fine, and cot theta.
Cosecant. 3/5.
3/5. Guys, do you agree with this? Do you guys agree with this? Welcome, Joseph.
Secant 5/4. Secant 5/4.
5/4. Secant?
Yes, sir.
No,
5/4, sir.
secant
I don't know this one.
Which one? You mean to say this one? I'm going to circle that.
Yes.
Yeah, secant 90 minus theta, which is the
This
reciprocal
one.
of cos theta.
Reciprocal of cosine 90 minus theta is 3/5. So this will become 5/3. 5/3.
Just a moment. Yeah, you're right. Very good. So cosecant becomes 3/4.
4.
This is 5/3. Am I
3/4. Yes, sir. 3/4. Yes, sir. That's correct.
Okay, I think no. I don't think so. Just a moment.
Sine
4/5, 3/5, 4/3,
okay.
and then cosecant becomes
5/4.
5/4. Very good. And then 5/3, and then finally 3/4.
Yes, sir.
3/4, right? Yeah.
4.
Yeah. Thank you. Yeah. So just match these things. See, 3/5 we have here. Let's take a different color. Maybe, yeah, this one. Just compare theta and 90 minus theta now. Okay, so 3/5. We have a 3/5 here. Can you see that?
Yes.
So these two are same, which means what? I'm writing here, cos 90 minus theta is nothing but, or which is same as sine theta, guys. Okay?
Okay.
So take the different values. I'm just trying to erase that one. So take the second one. 4/5. Where is 4/5? You can see here.
Sine 90 minus
So
theta.
sine 90 minus theta is same as
Cosine theta.
cosine theta, cos theta rather. Let's go for the next one. 3/4. Where is 3/4? You can check it down here, which is nothing but cot.
Cos tan.
Cot 90 minus theta is same as tan theta.
Tangent theta.
So if you compare others as well, tan 90 minus theta becomes cot theta, and the others are secant becomes a cosecant. Sorry.
3/4.
Yeah. So this cosecant becomes a secant. Secant becomes a cosecant. So we don't have a space here. Let's go to the next page. Do you understand, guys? So
Yes,
this is
sir.
nothing but a complementary angles of trigonometric ratios. So you will get, I'm pretty sure you will get at least one more questions. What is sine 90 minus theta? Sine 90 minus theta. What is the answer?
Cosine.
Cosine theta, just cosine
Cosine
theta.
theta.
Very good. So then cos 90 minus theta, it becomes a sine. Cos becomes a sine, sine becomes a cos in a
Okay.
complementary angles. Okay. So the next
Okay.
one similarly, tan. Tan 90 minus theta,
Cotangent.
cotangent. Excellent. And what else? We have you can take cot here. Wait, yeah. Cot becomes the tan. Cot 90 minus theta is same as tan theta.
Tan.
The finally cosecant
Tan.
theta. Cosecant 90 minus theta becomes
Sine.
secant. It's not
Secant.
sine. So it's not about a reciprocal, guys, here. So reciprocals is different, but this one is little different here. And finally, secant becomes cosecant. So these are the complementary angles of trigonometric ratios. Complementary in a sense, the two angles add up to 90 degrees. So that's what it is. Please let me know, guys, if you have any questions.
Okay.
Mohammed, have any questions? Joseph? Michelle, what about you? Do you have any questions?
Yes, sir. No questions yet, sir.
Okay, so that's great. Okay, so if you have any confusion,
Sorry, sir,
please.
I don't have any question.
Yeah, so please refer this thing. So it's completely, you can see that if you can compare any of the values, we'll get the C. We are comparing the cosecant here. The cosecant value is 5 by 3, varies 1 over 5 by 3. You can see that the secant 90 minus theta is same as
Cosecant
cosecant.
theta.
Yeah, so that's what I have written separately, guys. All these things. These are the complementary angles of ratios, trigonometric ratios. Yeah, so I'm done with the basics, or rather this one. So let's try some questions, or maybe word problems or something. Okay.
Okay.
Okay. Let me post some questions, guys. Just give me a second. Just a second. Okay. Yeah, I hope you guys can see the question now on the board, on the whiteboard.
Yes.
So how to solve this question? Try to draw a diagram if you can, so that is useful for us. The foot of a ladder is placed 7 feet from the wall. Okay. If the top of a ladder rests 8 feet up the long, how long the ladder is? You guys understand? So there is a wall like this, and there is the distance from the ladder, and let's call this is a ladder. If you want me to draw one more line, I think that looks better, I hope. So this is a ladder. Okay. So just assume this is a wall, and this is the distance from wall to the base of a ladder, you can say. Okay. So what is given? The foot of the foot of a ladder is placed 6 feet from the wall. Okay, the distance from the wall to the base of the ladder. Okay, that is what given. What else given, guys?
8.
Yes,
8 feet.
the height of the wall, or rather we can say the way, I mean, till the ladder rests, I mean, till that point, that is 8 feet. And what they're asking? They're asking us to find the length of the ladder. I hope you can see that it forms a right angle triangle here. I hope everyone agrees to this. So what you can do here, you can just use the Pythagoras theorem. Guys?
Yes.
I think I got the answer from Joseph. It's 10 centimeters. So 8 square plus 6 square equals to c square. 8 square is what? 64, right? And 6 square is 36. So if you add both, we'll get 100, guys. So c equals to square root of 100. What is square root of 100? Which is 10. So
10 feet.
yes, exactly, Joseph. Very good. So you need to write the final sentence maybe as a conclusion. The length of a ladder is 10 feet. Michelle, are you able to follow me?
Yes,
Is it
sir.
okay? So let's try.
Clear.
Yeah, great. So let's try one more question. I think I have one more. Here it is. I think again the one which is based on a ladder again. Okay, but have a look. Please read the question. The bottom of a ladder must be, yeah,
placed 3 feet from a wall.
yeah.
The ladder is 12 feet long. How far above the ground does the ladder touch the wall?
So we can also write the right angle triangle the other way around, like this.
Okay. The ladder.
So what is given? So 3 feet is
Excuse me, sir.
given.
I think for
Yes,
this kind of question also we have to use Pythagoras theorem.
yes, we have to use the Pythagoras theorem. Okay. So we are using only Pythagoras theorem. Yeah, that's what. So ladder, I think ladder length is given, which is 12 feet is given in this. How far? No. Wait, let me check the question again.
So the height is 12.
No. Yeah, I think the ladder is 12 feet. Height is 3 feet. You mean to say, Joseph?
Height is 3
So
feet, yeah.
the height is 12, I think.
No,
No,
the
it's 3
ladder
feet.
is given. The ladder is 12 feet long.
12 feet.
So this is a ladder.
Yes.
And the bottom of the ladder must be placed 3 feet from a wall. Okay. How far above the ground does ladder touch the wall? So what do you think? Height of the wall?
That one is 3 feet.
Which one?
The bottom.
The bottom one.
Yes.
Yeah. I think the question might be let me change the question. Something. You can see that how far the ground, I mean, from the ground, the ladder will touch, I mean, the wall. Yeah, so exactly. So which means that might be the height. We need to find height. So what is
The
height?
answer is 12.3. If you check.
Okay, so Joseph said 11.6 and Mohammed said 12.6. Let's see. So c square equals to a square plus b square. So that's okay. What is given? 3 square plus height square equals to 12 square. 9 plus h square equals to 144. H square equals to 9. Take away this one. How much?
11.6.
135. Okay, let me have a look. One moment, Joseph.
11.6 is the answer.
Okay, yeah. So 11.6. So I mean, this is based on the rounding. If the question is given, round the answer to 2 decimal places, we need to write 11.62 or something. Yeah. So I mean, here they haven't given any instructions, so it's fine to write 11.6. But based on the instruction, we need to follow. Exactly, Joseph. You're right. You're right. Okay, so let's try one more question, guys. Let's pick the good one. Yeah, I got one interesting one again. Let's see this one. Yeah, have a look at this. John leaves the school to go home. Okay. He walks. Okay. What I will do, I will draw a chart. I mean the graph kind of a thing here. Then you can decide which side is east, west, and all. Okay. So I will prefer this is east, west, north, south. Okay. Try to draw a diagram, guys. Can you please read the questions? John walks 6 blocks north side. So north side, in a sense, this is the side the John walks 6 blocks. Then from west side, he walks 8 blocks. And this is the starting point. I think you guys know the starting point. This is the starting point. This is where the John is now. And how far? What is the distance?
Then from the school.
Yeah. So they're trying to figure out this length. So this is 6, this is 8, and we need to find this, guys. You guys understand? So what I mean to say, if you are able to draw the diagram, I think most of the part is done. Yeah. So that's a 10, I think, right? So 10 feet or 10 blocks, you can say. The answer is 10 blocks. Dr. Michelle, are you able to follow me?
Yes, sir.
Okay. Mohammed, what about you?
Yes, sir.
Great, great. Joseph answered correctly. Okay. Okay. So finally, one last question, guys. Okay. So here it is. What is the length of a diagonal of a rectangle? Okay. So they have given the length and width, I think. So let's draw the rectangle, guys, first thing. That's what we'll do first. So that it looks like this. And then what is given? They have given this height or a length as a 15 centimeters and width as a 10 centimeters. So what they asking?
The area.
No, they asking us to find the diagonal length. So what do you mean by a diagonal? This is a diagonal, right? Or else you can take the other way around. Maybe.
So, sir, basically we need hypotenuse.
Yeah, exactly. So you know one side is 10, one is 15, and we need to find the diagonal length. How do you find that? I think you guys use the formula, right? Yeah. So I think we will get the what do you call it? The square root answer or the decimal answer. Please round it to 2 decimal answer if you don't mind.
0.02. Sorry, 18.02 is the answer.
Okay, let me have a look. Okay, 225. So c
325?
square equals to 325. C equals to square root of 325.
18.02.
Okay, I think you were right.
18.03 centimeter.
03, Mohammed here. Yes, Joseph, good one. So 18.0277, it goes on. When you round to 2 decimal point, the 7 we have, so it becomes a 03 centimeters.
Oh, okay.
Okay, but it almost approximately you can take it as a 18 if you want to. I mean, please use the instruction given in the question. Okay, so for rounding instruction, I mean to say.
Okay, sir.
Are you able to follow me?
Okay, sir.
Yep. So I think I'm done with the class. We'll try some questions. Please let me know, guys, if you have any questions.
Sir, is it?
No, sir,
Sorry, I have a question.
Yeah.
Do we only use Pythagorean theorem for right triangles only?
If angle is not given, if we are concentrating on only finding the side lengths in a sense, either the base or the height or the hypotenuse side, then we are going to use only Pythagoras theorem. Okay?
Oh, okay.
If we are using the angles, we might use trigonometric, or we have to use trigonometric ratios, the ratios which we learned at the starting. If you remember, go back to this one here, the trigonometric ratios. If angle is given, okay, if the question is based on the angle, then we have to use the ratios. If the question is based on only sides, then yes, Pythagoras theorem.
Okay, thank you, sir.
Yep, thank you. Any more questions? Do you have any other questions, guys?
No more,
Nothing,
sir.
nothing, sir.
Nothing. Okay, then. Let's try some questions if you want to. Okay. At least a couple. Okay, Mohammed, you want to leave? No problem. But if you guys want to try these questions, please go ahead. Michelle, you can try this as well. Ladder length is given. The base is given. We need to find the height of the wall. Okay. So this is what we need to find. Michelle, do you understand that?
Yes, sir.
Okay. So what might be the answer?
8 meters.
Yes, 8 meters. I hope you understand. So which is 10 square minus 6 square, which is 100 minus 36, which is 64. Square root of 64 would be 8 meters. Good one, Joseph. Want to try? Okay, so we tried many ladder questions. Let's move to the different one. Yeah. Okay, we tried the first one as well, I think. Second one, we can try the second one here. First one, just now we tried first one. I mean, sometime back. We can try the second one here. So given rectangle, diagonal length is given, guys. So if you want me to write that, so this is what the rectangle looks like. This length is given 25 inches and the width is given the 15 inches. So we need to find the length and then the area. Okay, I think Joseph understand. What about you, Michelle?
Yes. So
Okay.
that's only 100 plus 15 squared, right?
Which one?
10
This
number one. Number two.
number 2, you mean to say? First question or second question?
First question, sir.
First question, yes.
That's the square root of 10 squared plus 15 squared.
Exactly. So 10 square would be 100.
10.
15 square is 225. So and then we are going to add that 325. Then you need to take the square root of that, which is 18.03. Okay.
Okay.
So the next question, as you see, the diagonal length is given and the width is given. We need to find the area of a rectangle. So for that, you need to find the length first. How do you find the length? Use the Pythagoras theorem. So 25 square. What is 25 square? 625. What is 15 square? Which is 1 or rather 225. So if you subtract it, we'll get 400. So square root of 400 would be 20. So the length is 20 inches. And you know the area formula. Area equals to length into width. So 15 times 20. What is 15 times 20?
300.
300 inches square. Square inches. Excellent, excellent, Joseph. You understand, Michelle?
Yes, sir.
Okay, that's perfect. Okay. I do have one more set of questions if you guys want to try. Yeah. Yeah, this one.
The area is 81 square. Find the perimeter.
Okay, so just don't think about a question. It's not a difficult one. You just need to start it. Once you start, you will get an idea. So just draw a square first. Square, what is the formula for square? I mean, finding the area of a square, guys.
4 times the sides for S.
4, yes, you can say. No, that
For
is
S.
not, that is perimeter, mission. So I'm talking
Oh,
about the area, side into
sides
side.
times 4. Side times side, yes.
Side. So which is the value is already given. Side times side is 81.
81.
So side square is 81. Side value is square root of 81. So side would be 9 centimeters. So each side would be 9 centimeters.
Oh, okay.
36.
And you know the perimeter. You just need to add all. Excellent, Joseph. So 9 plus 9 plus 9 plus 9, or else 4 times 9, which is 36 centimeters. I hope that makes sense. Yeah.
Okay.
Yeah. I think the webinar went well. I hope you guys are able to follow me. Yeah.
Yes, sir.
Okay, then take care. Then see you in the next class. Please take care of yourself.
Thank you, sir.
Thank you, sir. Bye. Have a nice day. Bye.
Same to you, Joseph. Thank you so much. Bye.